Hi everyone. Uh, Today we are going to do 11.3 independent or dependent. So we are going to learn how to determine if the two events are independent or dependent. So before we start the lesson, let's see a simple question from the do now. If 40 people are surveyed about whether they like iOS or Android, the results are collected on this table. So like iOS as 7 people like iOS, also like Android, right? How about these 20? These 20 people like iOS but don't like Android. So total 27 like iOS. And these 12 people like Android, but don't like iOS. So 7 and 12 together, they like Android, right? And this one person don't like anything. So total 40 people. So if one person of the 40 is selected at random, what is the probability that the person likes both iOS and Android? Both. How many people like both? Here. The 7 people like Android and iOS. So what is the probability? 7 out of 40. Now how about, what is the probability that the selected person like Android, given that the person like iOS? What does given that does do? This is a conditional probability. So this condition narrow down the total sample, right? Total number of samples. So denominator will change. Total will be person like iOS. So where's like iOS? So we are dealing with only this 7, 20, and 27. So 27 people. So you should ignore don't like iOS, right? So from these 27 people, how many people like Android, right? So how many people like Android? 7. So 7 out of 27. Okay. Then what is the third question? What is the probability that a randomly selected person like either iOS or Android? It's not a conditional probability. So total will be 40 again, right? And what is the probability? So like either iOS or Android is a union. So which one is either like iOS, Android? 7, yes. This one don't like Android, but like iOS, yes, right? This one don't like iOS, but like Android, so it's either, it's okay, but one is not. So except the one, all these three parts belong to this A union B. So 39 out of 40. Get it? Yes. So now, before we start talk about independent, dependent, let's understand what is mutually exclusive events. Mutually exclusive means both events cannot happen at the same time. There's no common. They never take place at the same time like this. This is mutually exclusive. But this one, there's interaction, right? In between hearts and kings. So they cannot be mutually exclusive. But this case, ace and kings, there's no intersection, right? There is no common each other. They never take place at the same time. So they are mutually exclusive. But if they have a common like this one, hearts and kings, there's a king with a heart, right? So this one, these events cannot be mutually exclusive. Now, what is independent events? Independent events is an event that has no connection to another event, the chances of happening. So in other words, the event has no effect on the probability of another event occurring. So can you find any two events which are independent? Let's see with the example. Coin, and when you toss a coin, and when you roll a cube or die. So when you, regardless of the result of coin, the probability of cube doesn't change, right? So what's the probability of 1 from the, the cube? When the coin, has a head or tail, does it change? No. In this case, we say that they are independent. This coin never has any impact on the cube or cube to the coin. So, or regardless of whether if you keep going to school, whether it doesn't affect you going to school, then it's independent. But some people can be dependent, right? Some people, when the weather is really bad, they don't go to school. When only weather is good, they go to school. Then it becomes dependent. But no matter what, if you keep going to school, then independent. So dependent events, when the two events are dependent events, one event influences the probability of another event. So when you feel sad or happy, you choose movie differently. Then they are dependent, right? So let's see with the example. You have example like these two examples. Without calculate, so without calculation, you can even just by looking at it, you can determine this is dependent or independent. How? First, I can tell you, if you see this case, under 5 feet, look at under 5 feet, among the people who are under 5 feet, under 14 years is 20 people, over 14 years, 10 people. What is the ratio? 2 to 1, right? 2 to 1. How about over 5 feet? Over 5 feet, when you look at over 5 feet, under 14, over 14, if you see 36 to 18, still double 2 to 1, right? So regardless of the height, the under 14, over 14 is always 2 to 1. Then this is always steady like this, proportional. Same, then 2 to 1, 2 to 1 was same proportion. Then you can tell that these two events, the height and the age, are independent. But if you see here, this case, 21 to 12 and 9 to 58, obviously they are not proportional, right? Then they will be dependent. So let's try this time algebraically. So we need to know how to show this algebraically. Let's go. How do we show algebraically? This is the formula. P probability of A and B is equal to probability of A times probability of B. A and B is intersection, right? So probability of intersection of between A and B is equal to probability of A times probability of B. Then we can say that independent. If they are not equal, dependent. So let's see through the example. So 84 people are surveyed like this. Now let's see. What is event A? The person is 14 years old. The 14 over 14 years old is over 14. This is a event A. Event B is person is over 5 feet. Over 5. This is event B, okay? Just remember what is event A, what is event. Event A is over 14. Event B is over 5 feet. Then what two are they dependent or independent? We knew that by just by looking, we can determine they are proportional 2 to 1, 2 to 1, right? So we know that they are what is it, independent. But how do we show? So we should write down the formula. The PA intersection B is equal to PA times PB. We are going to use it, right? Let's go. So what is the probability of A? What's event A? Event A was over 14 years, right? So probability of A over 14 years is how many people? 28. And out of 84. 28 out of 4, right? How about probability B? Probability B over 5 feet, right? Second event B is over 5 feet. Total is 54 out of what? 84. That's the probability. But how about intersection? Both. So A and B, right? Probability of A and B is intersection, right? How many people are both? So intersection of A and B is 18. These 18 people are the over 14 years old and over 5 feet. Do you understand? So probability of A and B, A intersection B is 18 out of 84. So if you do this now, 18 out of 84 is equal to probability of A times probability of B. Can you write down and then put into the calculator and compare? Are they equal? 18 out of 84 is 0.2143. This PA times PB is also equal 0.2143. Oh, they are equal. Then how do you make a conclusion? Yes, these two events A and B are independent, right? Independent. So everybody understand how to determine if two events are dependent or independent. You remember this formula, right? P A intersection B is equal to probability of A and probability of B. You need to write down this. You need to remember this formula. You need to memorize this formula for independent or dependent. And then find out this probability, this, and this. And compare both sides. Do you get it? Okay. Then this case, obviously you will know, are they dependent or independent? It's a second example, right? Just if you take a look, these 21 to 12, 9 to 58, they are not, proportional. So they are dependent. But algebraically, let's do it. So event P, now this case, I said event P is over 14 years old, but same with A, right? And over 5 feet tall is Q, this one again. And this is A, this is B. So how do you get it? Probability of P is 70 out of 100, yes. And probability of Q is 67 out of 100. Intersection of both A and B is here, right? Intersection 58 out of 100. then are they equal or not? So 58 out of 100, you compare with the product of these and these, right? If you put into the calculator, this is 0.58 and this is 0.469. They are different. They are not equal. Then how do you say? How do you say? Yeah, this is dependent, not independent. Does everybody understand? So likewise, so now we have another, a little bit looks different. So now in this case, how do you say A and B are independent or dependent? We have a probability of A, we have a probability of B. Do we have a probability of A intersection B? Is this A intersection B? No, this is A union B, not the common, right? Not the intersection. Then we need to find out A intersection B, but we have enough information here. So do you remember the formula? P A union B is equal to PA plus PB minus PA intersection B. That formula we are supposed to use, right? So let's try this one. Now, can you move this one to here and this one to here to solve A intersection B? When you move it to the other side, change the sign, right? And minus becomes here positive. Now, to solve for PA intersection B, we know probability of A is 0.6, probability of B is 0.5, and then A union B is 0.8. If you subtract 0.3. So PA intersection B is 0.3. Are we done? No, now we need to determine, right? We need to determine that A and B are independent. So do you remember the formula? What do you do? So now you have PA intersection B, you have PA, you have PB. Then you set up the equation PA intersection B is equal to PA times PB. You need to make sure, right? So now PA times PB is here, 0.6 times 0.5 is 0.3. Are they equal? Yes, they are equal. So can we say they are independent, right? So that way, we are going to decide if two events are dependent or independent. So to determine if two events are independent, so do you remember what we need? Yes, we need the probability of A, probability of B, and probability of intersection B. When you don't have it, you need to calculate from this formula too. All right. So make sure we need a PA, we need a PB, and P intersection B. A and B is intersection. Then you can determine the independent or dependent. So if you keep going down, you will see 1, 2, 3, 4, 5 questions, and that's the ticket. All right, we'll finish. We'll stop here.